So in today's webinar, we're going to explain that IoT use cases in 5G, which also include some of the details brings of IoT and what the protocols being used for that, along with how this being used in 5G, which is a very recent technology. So in the contents, we kept IoT protocol. What is cellular IoT? Difference between the NB-IOT and LTE-M. Applications of IoT, and what does 5G mean for IoT? IoT use cases in 5G, and conclusion with the opportunities in different sector for the job. So next slide, please. So in the introduction, I would like to take you through the brief of what communication stands for. Like as we know that the communication is meant by the transfer of information from the source to the destination, and we have been using communication technology for years. And this being actually started over a long distance communication or telecommunication technology consists of electromagnetic devices and systems. Basically, this all being about transmission of information by various types of technologies over wire, radio, optical, or other electromagnetic system that I told already. It has its origin in the desire of humans for the communication over a distance greater than the feasible experience. Thus, slow systems such as postal mail are excluded from the field. The Internet of Things that describes the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. So these devices range from ordinary household objects to sophisticated industrial tools with more than 7 billion connected IoT devices today. And also we are expecting that the number grows to the 10 billion by 2020 and 22 billion by 2015. So that's the topic that we bring the IoT in this particular area. Next slide, please. So the concept of IoT lies that connecting any devices, so long it has an on-off switch to the internet and other connected devices, is known that is Internet of Things. So this is basically a giant network of connected things, and people, obviously, all of which collect and share data about the way they are used and about the environment around them. So this is basically a kind of system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifier and ability to transfer data over a network without requiring human to human or human to computer interaction. Next slide, please. So the Internet of Things platform devices and objects with built-in sensors and connected, which integrates data from the different devices, applies analytics to share the most valuable information with applications built to address specific. So this powerful IoT platform can pinpoint exactly what information is useful and what can be ignored safely. So if I tell you that example, something like Internet of Things can be a person with a heart monitor implant, maybe, or a farm animal with a biochip transponder, a automobile that has a built-in sensor to alert the driver when the tire pressure is low, or any other natural or man-made object that can be assigned an Internet of Protocol address and is able to transfer data over the network. Increasingly, organizations in a variety of industries are using IoT to operate more efficiently and better understand customer, to deliver enhanced customer service, improve decision making, and increase the value of business as well. Next slide, please. So to detect pattern, make recommendations, detect possible problem before they occur, this information can be used, which is a very wide applications of IoT, you can say. Let's say example that I want to know which optional components, leather seats or alloy wheels, for example, are most popular if I own a car manufacturing business. So that already explained that what kind of different kind of application we can expect from the IoT. So if I add something that how it works, so let that IoT ecosystem actually consists of web-enabled smart devices that use embedded systems such as processor, sensor, communication hardware to collect, send, and act on data they acquire from their environments. IoT devices actually the sensor data they collect by connecting to maybe IoT gateway or any other network which may be configured by any way. And also other edge devices where data is either sent to the cloud to analyze or analyzed locally. Sometimes these devices communicate with other related devices and act on information they get from one another. The devices do most of the work without human intervention. That is a basic thing. Although people can interact with the devices, that's also be the possibilities. For instance, to set them up, give them an instruction or access the data. Next slide, please. So, what is using the Internet of Things technology? What I can do, like use sensor to detect which areas in a showroom are the most popular and where customers linger longer. So that kind of applications nowadays is very important to have. So and also in a era of machine learning and artificial intelligence, the devices, the approach that how we can use the devices in our day-to-day activity by which you can gain something in wherever field. So that is the main thing that IoT came into the picture. And one another like drill down into the available sales data to identify which component are selling faster. So that's the thing, that's the major thing that IoT can, if IoT implement, we can get the benefit from out of it. And also to keep popular items from going out of stock, automatically align sales data with supply. So that's also a case which been written as an example. Next slide, please. Now the very important is IoT protocol. IoT protocol is kind of technicalities which IoT is having with, and it is very important to understand that what is all about. These technicalities, it lies completely on the communication system. So IoT protocols are an integral part of the IoT technology stack. And without this protocol and standards, hardware would be deemed useless as IoT protocols enable the IoT extents that I told already. So this is very crucial part that I mentioned, and and without them, hardware would be rendered useless, as the IoT protocols enable it to exchange data in a structured and meaningful way. Out of this transferred piece of data, useful information can be extracted for the end user, and thanks to that, whole deployment becomes economically profitable, especially in terms of IoT device and management. So when we're talking about the Internet of Things, we always think about the communication. Interaction between sensors, device, gateway, servers, user applications is the essential characteristics that makes the IoT what it is. But what enables all this smart stuff to talk and interact are the IoT protocols, which can be seen as a language that the IoT gear uses in order to communicate. So there's a few protocol which is very important, which is lies in IoT protocols. The first is that CoAP protocol, which the full form is Constrained Application Protocol, which is a very important one, and existing internet infrastructure is freely available and usable for any IoT devices. It often proves too heavy and power consuming for most IoT use cases. And another is very important, that is MQTT protocol, which is message queuing telemetry transport, which is also the most wide adopted standard in the industrial Internet of Things to data message queuing telemetry transport. And another is, and also in this particular protocol, there's a pros are there, like a minimum bandwidth use, operations over wireless network, low energy consumption, good reliability, and also the processing time and the uses of memory is very low. Another is Wi-Fi, which is very well known, and also the Wi-Fi network requires devices that can send wireless signals, which means devices such as telephones, computers, routers. So it's very well-known application that we can use. Also, some of the like Zigbee also is there, which is also a low power consumptions, but the throughput is very low in this particular application. Bluetooth are also there, and also the one is that is extensible messaging and presence protocol, which is very also important. This very old, and this is actually meant for the real-time messaging communication IoT protocol for message-oriented middleware is based on the XML language actually. It actually allows for the real-time exchange of structured but extensible data between two and more network lines. So that is, and also one is data distribution service DDS, which is also been published subscribed methodology designed by the object management group. Actually, DDS protocol for the real-time M2M communication, which is also meant for the 5G as well. And another is advanced message queuing protocol is also open standard protocol. Another is lightweight machine to machine, which is also protocols applied in IoT that is has been specially designated to meet the requirement for the comprehensive handling of the resource constrained devices. So these are the main some of the basic protocol. And also we need to know that why should we care, and what is the basic thing on it. So that smart devices from its ordinary counterpart is that while the latter stays mute in case of breakdown, the former is able to talk to the other devices, and if encounters any problem, if need, communicate the failure to the user or automatically call for a help. But every such instance of interaction is only possible when there is a medium of communication, a common language. So that uh, brings out all about the protocol is. So this about the basic thing about protocol, which is very important to understand to work with the IoT, because without understanding, we cannot understand how hardware works, how it works, and where we can implement, how we can implement for the for our own desire. So next slide, please. So then what protocols do IoT qualified devices use? So these protocols and standards are broadly classified into two categories, that is IoT data protocols and network protocols. So if I comparing, maybe everyone knows that the Wi-Fi layer for our common technology for 2G, 3G, LTE, and 5G. So if I comparing with that particular thing, so we can say that presentation and application layer to be mapped with the data protocols of IoT, and the network protocols is lies in the data link and physical layer. So this actually we can understand better if we can, as we all know that what OSI layer and how it functions. So that makes sense then how IoT works with touching with communication OSI layer concept. Yeah. Next slide, please. Now we come to the difference between NB-IoT and LTE-M, which is actually a cellular IoT, you can say. So actually, connectivity enables the communication, what makes up the heart of the Internet of Things. IoT devices is actually communicate with the gateways, and the gateways communicate with the cloud, often via cellular data connections. And but there are so many technologies in relation to IoT connectivity, and that is very easy to get lost in all options. So many of companies begin to investigate the possibility of deploying the IoT project. However, it is increasingly important to understand the various connectivity offerings so you can match your company's specific needs to the right solution. In general, IoT connectivity falls into the one of the three categories, that is cellular, local personal area network, LAN or PAN, and low power wide area network, that is LPWAN. So in this particular thing, we are talking about the cellular category, that is LTE-M and NB-IoT. So what makes a difference between two? So if I just take you to the some background, that MTEM and NB-IoTs actually were created by the cellular industry in response to the rise of that low power wide area network technologies, LPWAN technologies, which were specifically developed for the IoT use cases. And these new cellular standards were designed to support device communication via carrier network in a way that's less expensive, more power efficient than traditional telecom standard we know as a 2G, 3G, 4G, or 5G. So, what is LTE-M then? LTE-M, before LTE-M, there was a several categories of high-speed LTE, the standard of wireless broadband communication for mobile devices. Also, using LT4G for IoT devices was not very power efficient because the chips used to talk to cellular had a huge excessive amount of battery power to identify the relevant message. So what happened then? LT was deemed in inefficient connectivity method for IoT devices, and alternatively, we begin to emerge. Seeing the need for IoT-only network technology, 3GPP, the standard organizations that develop protocols for mobile communication developed LTE-M, also referred to as a LT-CAT-M. So actually, LTE-M is stripped down to the version of LTE, and it uses the same spectrum, base stations work everywhere that LTE works. So the major difference between LTE and LTE-M, if we, in a simpler note, which means battery-powered IoT devices can send and receive data online via cell phone carrier networks in a more power-efficient way. Like and if you know that iPhone battery lasts a day, but a cell modem connected water meter battery could last years. So a significant improvement with regards to the cellular IoT devices. However, LTE-M requires a more battery power than NB-IoT, so that is a major difference. So one of the reason LTE-M is more costly connectivity option is because several large players have patents on underlying technologies. LTE-M users pay royalties to these companies for the use of their intellectual property. Now, what is NB-IoT then? Uh, LT was a way too complicated for IoT and wanted to create a something new. So the cellular protocol they envisioned called NB-IoT and was developed specially for the devices communication using simpler, cheaper chips that require less power. And it also makes use of a small, often pieces of the radio frequency spectrum. Uh, Although NB-IoT is a fairly attractive connectivity option, it is currently more prevalent in Europe and Asia. It is still not widely available in US, although some carriers like some of the basic broadband services that have been covered in small spaces. And despite that fact, NB-IoT has a good promise. There are load of 20 kilohertz GSM spectrum assets that are not being used, and proponents want to use NB-IoT deployed on it. So NB-IoT is basically then does not have an intellectual property pedigree that, but that what LTM has, which mean user pay less in royalties in that case. So NB-IoT and LTM are not your only options for connectivity. If you are interested in learning more, then there's a all other thing as well. So yeah. So these are the main that cellular IoT has proposed and been working as well. Next slide, please. So basically that difference that I already mentioned, and more obvious to say that Internet of Things is one of the driving force behind the concept of Industry 4.0, which is all about the IoT and enhancing automation, data collection, analytics to optimize process, workflows across the industries, but also influencing our daily lives way more than we have expected it by the third decade of 21st century. So that is a major thing because the industry 4.0 for AI powered technologies that deliver insights to cut downtime industry process, and that is main these new IoT applications been rolled out and been hugely been uh, uh, spread over the network. So this is all about this. Next slide, please. Now, in the last year, analysts have highlighted the rapid growth within the Internet of Things sector, estimating that around 41.6 billion things. And as I also mentioned, that what billion can be reached in 2025 globally. So, according to the studies, that much of this growth will come from the cellular IoT. So that is the devices connected using the mobile network infrastructure that we use daily when transmitting our voice data to and from mobile devices like smartphones. So, that is the main thing that uh, the NB-IOT LTE-M that initially deployed for the purpose of connecting the IoT applications to the cellular network. But what we found that the devices are not that as having the capacity like cellular. So that's why the power was a major concern. And also we cannot generate in our application as well. I found that the traffic was not that high in IoT, so we cannot generate with the traffic through the IoT, but the connectivity applications must be very smoother with all these applications. But yeah, NB-IoT comparing with the power consumption way better than LTM. Okay, next slide please. So a few data across many miles, cellular IoT technology enables piggybacking on the existing dense and reliable GSM infrastructure, which means improved performance and economy at the same time. This is the one factor behind its popularity. As NB-IoT is deployed, the IoT that we found that been mainly deployed initially in LT, but that was not, as I also mentioned, that was not quite accepted as our expectations. But when we deployed in the GSM 900 frequency or any other GSM frequency, mainly in 900 frequency, that's mainly been deployed. So that's the huge chunk that while in this era the 2G or GSM technology also been to some extents are not being used. So that's so we can use that IoT options in that particular frequency range. So we have that to be back in our particular cellular technology. So that's the one option we could find. And also the installations of that ad in particular frequency will really come out with a good advantage on that particular thing. Yeah. So now it must be made obvious that the standard and well-established cellular options such as 2G, 3G, LTE are highly power hungry. As I already mentioned, and 3G mainly is very power hungry. Thus, do not go well with the usual IoT applications where only small amounts of data are sent intermittently, such as smart meters, agriculture sensors, and actuators, asset tracking devices, smart healthcare gear, and many more. So, as I already mentioned, the traffic, if I consider about traffic, so we cannot comparing with the uh, uh, normal cellular smartphone with the IoT application. So that's way different. So now we are talking about data on the terabyte, but even in IoT, the data that we could see on kilobyte either. So we cannot comparing with the traffic, but yeah, there's a lot of applications, as I told, that connected applications must be very useful over here. So that is the main thing. And also, if you're talking about the power, IoT cannot be compared with the power with the cellular, because it's a very small devices with the minimum hardware for a particular purpose. So that cannot be compared. Although they somehow try to be sync with the existing technology by which we can use that. So that's somehow been managed, but yeah, obviously it cannot be comparable. Next slide, please. So that's about the cellular IoT in IoT 4G, LTE, 5G. Now 5G came into the big picture, so we'll see that how IoT will be working 5G. Next slide, please. Next slide, please. So, as I told, that highly complementary cellular to IoT solutions, they address different type of use cases based on intensity of the capabilities and the two technologies. Even the slightest difference in the performance and data plans of each technology that can have a huge impact on the operation of any IoT project implementation. So, whether it is a small scale of deployment or multi-million device bit. So that is, you can say that our rivalry existed there, but with allies as well. So yeah, so that is the basic difference that already been explained. Yeah. Next slide, please. So that's all about the. We can come to the conclusion that how both come to the synergy with rivalries allowed with allies. So yeah, next slide, please. Some of the application connectivity solution depends largely on the main points of strength that each of the technology has. As for LTE-M, has an overview of its advantages along with some use cases they are suited to, like throughput compared to its main narrowband opponent. Throughput is really comparable in LTE-M as there's been working with the LTE, so we can expect that we can have some better throughput in case of LTE-M compared to the NB-IOT. Lower latency as well. So it is very important. Latency in IoT application is very important because whenever we are talking about the connected device, so if you will not get that desired latency, then it's useless basically because some of the application to be in real time scenario. So if there is a latency is not matched, then will it will not work and it will not actually solve our purpose as well. Then better mobility and thanks to the roaming and more comprehensive use of the LT infrastructure, as I already mentioned, that obviously the infrastructure wise, throughput wise, the payload wise, and latency wise, the infrastructure is not comparable with the GSM or any other legacy technology. So due to have that in infrastructure in LTE-M would be really not comparable with the legacy RT. So, but yeah, obviously it's obviously due to the LTE infrastructure we have again these things from the LTE-M. Yeah. Next slide, please. So, what are the applications? High power efficiency at medium data rates. The more data is sent, the more efficient the solution becomes. Obviously, suitability for TCP/TLS secure connection, which is very important. The security in this particular connecting devices is very important because the application that we use it requires a bit of security. Otherwise, it will really we lose the trust from our customer. So that allows the direct secure device cloud connections, manages the overhead involved in the communication. A thing that is not really possible with narrowband interrupting because of its limited throughput. That's also been a concern already. I told that that's the thing. Due to the narrowband IoT, we cannot have that desired throughput. Although it, if I talk about some of the example of the devices, some of the users not require that throughput, so that can be applied in for the narrowband IoT. Otherwise, which require some of the applications require a very real-time activity, so that's require a low latency with a high throughput. So in that case, the LTE-M is way better than the NB-IoT. Yeah, but yeah, the applications so far so concerned. So yeah, it's really have much. There's a lot of applications for the IoT, both for the LTM and NB-IoT in our recent day to day, along with our necessity, obviously. So, next slide, please. Some of the application like asset tracking, healthcare gear, wearables, retail vending machines, smart home security, sea of other users that require relatively high data rates combined with energy efficiency. So that are the main application nowadays by the LTA, where the NB-IoT is not performed well. So this kind of application, as I told, that some of the applications require very high throughput. So like this kind of the healthcare gear and wearables, it's require a very low latency. Otherwise, it would really uh, fail to fail our to reach our expectations. Smart home security also, this require very low latency, and LTE-M can only be supported in that particular applications. So these are the main applications for the IoT nowadays. Apart from that, a lot of other applications we can expect from this particular Internet of Things. Yeah, next slide, please. So on the flip side, the strength that we get with the NB-IoT are longer range. Obviously, the higher the frequency, the lower the range. So that's coverage we can expect. So if we implement in the GSM, we could expect the range would be much higher compared to LTE. Better penetration, obviously, of signal within buildings or the difficult terrain condition, greater efficiency at very low data rate, more cost effective data plans. So that's very few example we can expect that what the legacy technology can support. Like GSM, we have a high penetration, longer range, greater efficiency and low data rate, more cost effective, obviously. So that's how the NB-IoT works. So for our some purpose, maybe that helps, and that due, due to these two test separate IoT applications been launched and in into different technologies. So we can have both pros and cons for different technologies. So we can take away some good things from the GSM. So where the NB-IoT been uh, implemented to get the benefit and get the rip out of it. So that's the thing the NB-IoT is all about, and NB-IoT applications in GSM along with this it's positive vibes that we can get. Yeah. Next slide, please. I think so with such advantages on board, narrowband IoT is best suited in the following fields like smart metering, smart agriculture, environmental monitoring, smart city, and the list may go on and extend to every use cases that require a greater battery lifetime, low bandwidth utilization, extend range. As I already mentioned that well, we are when we are talking about NB-IoT, we could expect what it can deliver. So that's some of the application which may require low bandwidth, which may have a low throughput, high latency. So if this purpose are solved, so that's the application we can take the benefit from the NB-IoT. So that's some of the application which not require that high high bandwidth, low, very low latency. So that's this kind of application we can NVIDIA can solve easily with its technicalities. Yeah, next slide, please. Yeah. So now here we are in 5G IoT. So what does 5G mean for IoT? So 5G here, and it's there to change the game, and so they say like but what does that really mean for you? Like well, it that one can one we know for sure it can be a 5G IoT is really a catalyst for the development of Industry 4.0, and there is a better chance than not that your industry is already a part of that revolution. So we have innumerable studies that are trying to quantify and predict the material impact of fifth generation and the Internet of Things. And some of these focus on the cost aspect, other on the value to the society. However, even as these studies are still ongoing, and it is evident that 5G will spur innovation across many industries and provide a platform enabling emerging technologies such as the IoT to become an integral part of our economy and lifestyle. So 5G is the foundation for realizing the full potential of IoT that we didn't get from the LTE and GSM that we already discussed. So we want to take the full benefit is because 5G is not about the speed, 5G is not about the throughput. It's all about the applications. 5G consists different a lot of applications that it can support, and IoT is one of the most potential application where we can get a full benefit from this particular technology. So while 5G is set to for commercial availability sometimes around 2020, the industry is all already working to develop a new global standard and a pre-5G products to benefit industries everywhere. And also, the Ericsson also point out that there will be a 550 million of 5G subscriptions, maybe in I guess 2023 or 2021 2022, I guess. And also Asia, throughout the Asia also the second fastest growing region for that particular subscription in 5G. So this is more than just a speed, you can say. And also one way to 5G and Internet of Things is that with connectivity at the heart of the industry transformation, 5G will have a key role to play, and not just in the evolution of communication, but in the evolution of business and society as a whole. On the road to the 5G, operators, will need to do more than just evolve networks. They will need to transform their business to address new opportunities. Operators really have the connected phones, tablets, other devices, but connecting and managing growing number of cars, even meters, machinery sensors, consumer electronics profitability will also require innovative business model. The vast majority of operator IoT revenues actually come from the connectivity, although in the next 5 years, the revenue will also come from service enablement platforms, apps, service, and also operators capable of creating and managing on ecosystem of service partners, refining data from their IoT platform and turning bulk data into the smart data will be able to create incremental revenue based on the value of data rather than just a volume. So, basically, IoT presents both operators and industries with a fertile ground for innovations and the new ways of engaging their end customers. And key success factor will be the also ability to launch new services with a short time to market from idea to commercial offering, combined with the right business models and access to a rich array of complementary offerings from ecosystem partner. So that is a basic futuristic story on 5G and over the IoT. So yeah, next slide. So this is how it's being connected, and as I already mentioned, that 5G is not about the speed. It's beyond that, and we actually it's actually based on the application space technology that will bring a huge revolution in the society. So that is how we are will going to be connected, and it's a connecting society, we can say, which will bring by this new radio 5G, and IoT also be one of the huge role, and also bring a huge efficiency in our communication journey so far. Yeah, next slide, please. So 5G mobile communication technology actually designed for various variety for vertical IoT use cases with demanding requirement like gigabyte data rate, millisecond latency, ULLC, that is ultra high network reliability, massive. So that's as I mentioned that it's not about only the speed. It's about also the millisecond latency. If you could expect that the health sector uh, will get a huge benefit and get a huge uh, the efficiency that we get from this, because latency is really very big role, a big role in the legacy technology. So if we could reach that level, we'll have a huge benefit out of it. So also this is some of the use cases. And next slide, please. So like, yeah, so what are the use cases then? So some of the like vehicle telematics, in vehicle infotainment, smart grid automations, mobile and collaborative robots, video surveillance, cooperative intelligence mobility. So as I mentioned, it's beyond our expectation that what can we achieve through that. IoT along with the 5G, because the infrastructure will having with 5G, and if we just plug in that IoT into it, it will create a, you know, it, the application that we can bring into it will have a huge efficiency in our society, along with the connecting society that we dreamed it's will so far it will definitely become a successful. So that's some of the major applications out. Apart from that, there's also huge applications, and that also the working we already the things have been working on. So maybe when the full deployment we can see in our network, then obviously we can have that other applications as well. But yeah, so these are the major applications that we could think about, and also the 5G along with the IoT will have a bigger role into it. Yeah. Next slide, please. So yeah, so far we saw that what are the major applications IoT what already implemented and what are planned for the new radio. So there's a lot of R&D been ongoing in that particular thing, and also the service delivery, because the operators, the service provider, they are working on it. Many where the IoT new radio has been already been implemented, and engineers are working on it. So on that point of view, there's a lot of opportunities will definitely come and already in place as well. So some of the companies like Amdocs, Vodafone, Airtel, Ericsson, Huawei, these are the major service provider we can where they are continuously working on it along with R&D sector. So that's the opportunity that we can expect from here. And also there's a recently the requirement to IoT expert and inner expert, and how this has been working and how we can work on it. So that's the opportunity is floating over. So that's we can expect, and obviously the more to come, obviously. And some other small recruiters also there, TCS, Samsung, Tech Mahindra, British Telecom, they're also working on it. They're also trying to uh, 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 you know uh, their hand into it to try the full get the full benefit of how this technology, because these are huge, in coming days, the requirement, the expectations, how this will work, it's a huge. So we can expect a move for it. So yeah, so that's I think we can come to the conclusion here.